So this is question number 4, I think it is, for the 26.5, page 716. This is homework from worksheet 11. It says, show the ratio test cannot be used to show that this is convergent. Okay, so when we apply the ratio test is going to look like this. So the limit as n goes to infinity of 4n plus 1, n plus 1 factorial squared over 2n plus 2 factorial. Okay, so then we simplify, over 4 to the n plus n factorial squared over 2n factorial. Okay, so just move that limit down a little bit. Okay, so we want to pair these up and simplify this. So we get the limit as n goes to infinity. This is going to be 4n plus 1 over 4 to the power n. So it's going to be 4. Okay, we're going to end up with n plus 1 squared, n plus 1 factorial squared over n factorial squared. So I'm just going to group those together and put the squared on the outside. And we're going to end up with 2n factorial over 2n plus 2 factorial. Okay, so working this out, we get n goes like this, and this works out to be 4 times n plus 1 times n factorial over n factorial squared. So those are going to cancel out. Here we're going to end up with n plus, or 2n factorial over 2n plus 2 times 2n plus 1 times 2n factorial. Okay, so these factorials cancel out. And then simplifying this becomes the limit as n goes to infinity of 4 times n plus 1 squared, so n squared plus 2n plus 1. Okay, I'm going to put that in the numerator here, so it's going to be 4 times n squared plus 2n plus 1. In the denominator, I'm going to end up with 4n squared plus, that's going to be times 2 times, it's going to 6n plus 2. Okay, looking at the ratio of the highest powers, this just ends up being equal to 1. Okay, so our ratio test, okay, again, we want it to be less than 0, but in this case, or sorry, less than 1, but in this case the ratio is equal to 1, okay, meaning that if the ratio test is equal to 1, it's inconclusive. Okay, so that's a bit of a problem. So how do we resolve this? Now this second part is actually a really hard question. How do we actually determine whether that, in fact, they tell you it's divergent, but how do you tell it's divergent? So I had a bit of a problem with this myself, and so I wasn't actually sure that it was divergent, and so I had to check it myself, and when I did check it, yes, it was divergent. And it was divergent because this nth term doesn't actually go to 0.